The empirical rule, or the 68, 95, 99.7 rule, applies to the normal curve, the standard normal curve. And I wanted to just talk about this rule, and really it is the definition, it's what makes something normal. So in the middle of my distribution, I have the average, the mean. Okay? And the idea, as I stated in an earlier video, is that most things are around average. And the more extreme I go with outcomes, the less I see those outcomes. And my example was heights. Most people are approximately the average height. And as I go really, really tall, I have less people. And as I go really, really short, I have less people. So it follows this general curve. Now, within one standard deviation, a standard deviation is a measurement of spread, okay? Within one deviation of the average, I will find 68% of outcomes. Now, I like to always put a number with this when I talk about it, and I usually use something like a test. Let's say we had a test that had an average score of 75. This mu is oftentimes the symbol for average, and it has a deviation of 5. So 75 goes right here, and if I say, well, 5 points higher is 80, and 5 points lower is 70, if I said to you, how many students scored between 70 and 80, you'd say 68%. But we also then, using the graph here and the symmetry, could split this in half and say, well, 34% here and 34% here. So this way I could say, well, how many students or what percentage of students scored between 75 and 80? 34% did. All right, let's do another. If I went a second deviation out, so let me put those scores here. Again, 5 more points down, 5 more points up. Within those deviations lies 95% of all outcomes. 95%. So again, if I said, well, what percentage fell between 65 and 85? 95% of all outcomes. Now, doing some quick math, we could, split this. We could say, well, that means there's 47 and a half of 95 that lies between 65 and 75, half of that 95%. But I could even go further and say, well, that percentage minus this 34 allows me to fill in 13.5% here and 13.5% here. Again, where I came up with that is this whole span was 95%, so if I divided it in half, I would have 95 divided by 2, 47.5 in this span, and then I just subtracted off the 34% there, okay? The final number that goes with this empirical rule that deals with 3 standard deviations away, so again, 5 more points, and 5 more points, like that. This percentage is 99.7%. So almost everybody. Okay, we're just missing that 0.3%. And because I like to fill in these things, that 0.3 would mean I'd have 0.15, splitting the 0.3 on both sides, I'd have 0.15 on either end. And this could then allow me to kind of fill in this other piece because, I've got 95% included, meaning I got 2.5% outside, so I could do 2.5 minus 0.15. There's 2.35% here and 2.35% here. Now, if you were asked, what is it that makes a normal curve normal? It is these numbers and this breakdown. This is the definition of the normal curve, that it follows these percentages. On the other hand, if someone said, hey, I collected a bunch of data and I graphed it and I calculated what proportion lie within these deviations and I came up with this, what does that mean? It means that curve is approximately normal. Now, in real life, a lot of times we say it's approximately normal, a distribution of data. Maybe it wasn't exactly 68, 95, 99.7. Maybe it was 67 and 96 and 99.3 or something, just a little bit different. And like I said, we often say that's an approximately normal curve. But to be normal, these are the percentages. Now, these allow us to do a lot of things, answer a lot of questions. Like if I said on this particular exam, what percentage of kids got between 65 and 80, you would just add these numbers all together. If I said what percentage got higher than 80, you'd come to 80 and you just add those numbers together. If I said what percentage got less than 65, you'd start here and you'd add those percentages. So we have a lot of things we can do with this empirical rule and talk about what percentages lie within these values. But the problem is we don't have any way to talk about values that aren't a full deviation away. Like what percentage of kids got higher than 83? Well, I don't know. We could do what's called a z-statistic, a standardizing score, and I'll talk about that in a later video. But empirical rule only deals with these whole values away. And just in an effort to show one more example, let's say I had a different thing. Let's say I collected information about heights. So let me just kind of cross off these values that I have down here. And let's say I said, I have a height I collected, and the average height was 64 inches with a standard deviation of 3. And you could say the mean is 64, and then go down 3 and up 3. There's one deviation out. I could go down 3 units, up 3 units, down 3 units, up 3 units, like that. And again, now I can say the percentages stay the same. All that changed was the scale on the bottom. What percentage of people are more than 67 inches tall? Come here, add those percentages up. What percentage are less than 64? Go here and add those percentages. What percentage are between 58 and 64? Just add those percentages. So those numbers are worth learning, especially the big ones here, the big 3. And oftentimes, like I said earlier, an empirical rule is sometimes called just the 68, 95, 99.7 rule. If this video helped you, please like and subscribe for more math help.